Okay, this is your lesson for 11.2, which is talking about solely about arithmetic sequences. Alright, with the arithmetic sequences, remember they have a common difference, okay, between the values. Okay. Alright, they follow a particular pattern. Every arithmetic sequence can be written in the form t sub n is equal to t sub 1 plus the grouping of n minus 1 times d. T sub 1 is equal to your first term, and d is equal to your common difference. Okay, so let's look at some examples that use this. Okay, this first example is going to talk about find a formula for the nth term of each arithmetic sequence. Okay, so the first one, number 2, is 30, 20, 10, 0, and so on. Okay, so we first realize is we're subtracting 10 each time. Okay, so d is equal to negative 10. Alright, and if d is equal to negative 10, then t sub 1 is equal to 30. And so I just fill it out. T sub n is equal to 30 plus n minus 1 times negative 10. Okay, and we can simplify that further, and we will. We get 30 minus 10n plus 10, or t sub n is equal to 40 minus 10n. Actually, I'll rewrite that. Do negative 10n plus 40. Okay, we'll do the same thing for the next one. This is 6. We want to do 13, 4, negative 5, and negative 14. Dot, dot, dot. Okay, so we look at it. We know it's arithmetic because they told us it's arithmetic. In each case, we are subtracting 9. Okay, so we get a common difference. D is equal to negative 9. T sub 1 is our first term. That's 13. So T sub n is equal to our first term plus n minus 1 times negative 9. It's 13 plus minus minus 9n plus 9, or T sub n is equal to 22 minus 9n. Okay. So we got that, and we got that, and those are those type of examples. Okay, our next set of examples want us to find the specified term. Okay, so if I look at number 8 has the values 3, 11, 19, and so on. They want us to find t sub 31. Okay, well, good news here is I need to know a formula for t sub n. T sub 1 is 3, d is 8, so I get 3, and so I actually don't have to do anything more than that because I want to know t sub 31. So t sub 31 is equal to 3 plus 31 minus 1 times 8. So we've got 3 plus 30 times 8, or 243. Okay, another example like that. Number 12. We've got 17, 7, negative 3. And we will find t sub 1,000. Okay, so t sub 1,000 is equal to t sub 1 plus 1,000 minus 1 times d. d is negative 10. So I get 17 plus 999 times negative 10. 17 plus 999 times negative 10 is negative 9,973. Okay, another example doing the same thing. 14. They tell us t sub, it's a little bit different. They tell us t sub 2 is equal to 7 and t sub 4 is equal to 8, and they want us to find t sub 1. Okay, so they don't give us a lot of information other than n and t sub n. When that's n is 2, t sub n is 7. When n is 8, or when n is 4, t sub 4 is 8. Okay, so there's a couple of different ways we can do this. I'm just going to use our formula. T sub n is equal to t sub 1 plus n minus 1 times d. There are other ways to do this. This way will work for most every one you see. You get 7 is equal to t sub 1 plus 2 minus 1 times d. Okay, and you get 8 is equal to t sub 1 plus 2 minus, or so not 2, 4 minus 1 times d. That's a system of equations. Actually, that's 7 is equal to t sub 1 plus d, or 8 is equal to t sub 1 plus 3d. Okay, and so since we're trying to solve for t sub 1, I will make this a little bit different. Now I will go and let's do negative 3 there. Alright, that'll cancel the d's, and so if I take those two, that gives me negative 21 is equal to negative 3 t sub 1 minus 3d. I've got 8 is equal to t sub 1 plus 3d. And then if I add going down, I get the expression negative 13 is equal to negative t sub 1, or 6.5 is equal to t sub 1. Alright, so that's 14. Same type problem, different setup. Okay, so this is 18. We've got t sub 10 is equal to 41. We've got t sub 15 is equal to 61. And we want to find t sub 3. Like I said before, there are other ways to do this, but I'm just going to treat it by finding the original equation, 10, 15, 41, and 61. Those are the points given to us. So that means 41 is equal to t sub 1 plus, not n in this case is 10, plus 10 minus 1 times d, I don't know d, or we got 61 is equal to t sub 1 plus 15 minus 1 times d. Okay, so those simplify to 41 is equal to t sub 1 plus 9d, or 61 is equal to t sub 1 plus 14d. So got to find d and t at the same time. I'll just do this way, eliminates the t, I get negative 20 is equal to negative 5d, or my common difference is 4. Okay, if I know my common difference, I can find my original value, or I can find the initial value, t sub 1. Okay, so 41 is equal to t sub 1 plus 9 times 4. Alright, so that gives me 5 is equal to t sub 1. So my generic equation, t sub n, is equal to 5 plus n minus 1 times 4. And I want to find t sub 3. So I plug in 3 for n. And I get 5 plus 8, which is 13. Alright, and so that gives me t sub 3. Okay, next I want to talk about arithmetic means. You have some questions about arithmetic means for your homework. First off, the arithmetic mean between two numbers a and b, we just add them together and divide by 2. Okay. For example, if I have 6 and 30, well, the arithmetic mean is 36 divided by 2, which is 18. Y'all know how to do that part. What you don't know is we can set it up a little bit differently with arithmetic means. Okay, if I have the digits 10, or the sequence 10, 13, 16, 19, 22, there are 3 arithmetic means between 10 and 22. Those 3 being 13, 16, and 19. Or, if I have the digits 10, 14, 18, and 22, there are 2 arithmetic means between 10 and 22. Alright, arithmetic means. Okay, so what does that mean for you in your homework? You look at problem number 24, it wants us to find 2, 3, and 4 arithmetic means between 15 and 45. So essentially what we've done is we've got a measurement here. We go 15 to 45. We want to know 2 arithmetic means. Those are there and there. Or if I do the same thing to get 3, 15, and 45, or even the same thing to get 4, 15, and 45. Now remember, when you're doing this, these are all the same values. So I can find the distance between them easier than I can find the values. All I've got to do is say 3x is equal to 45 minus 15, or 3x is equal to 30, which tells me x is equal to 10. So that makes that 25 and 35. Or I do 3, or not 3x, because I've got more x's here on the next one. I've got 4x is equal to 30, or x is equal to 7.5. And so I get 22.5, I get 30, and I get 37.5. Or I get 5x is equal to 30, or x is equal to 6, which gives me 21, 27, 33, and 39. Okay, so that's the 2 arithmetic means, 3 arithmetic means, 4 arithmetic means. Alright, so that takes care of 24. Last example I'm going to work for you is number 28, which says how many terms are in 44, 36, 28, out to negative 3, 80. Alright, so, well, there's a couple of different ways I can do this. this particular way, I know t sub 1 is equal to 44, d is equal to negative 8. So my term is t sub n is equal to 44 plus n minus 1 times negative 8. Okay, so I've got 44 minus 8n plus 8, or t sub n is equal to 52 minus 8n. Now, what I know is I want to know what is n equal to. What is n equal to when we've got negative 380? So what I can do is I can do negative 380 is equal to 52 minus 8n. Now tell me what n is. So I just solve that. I get negative 432 is equal to negative 8n, or I get 54 is equal to n. So my answer is 54 terms are in that particular sequence. Again, that's just write the formula like I did here. Okay, I did first term, t sub 1, d. Okay, that's from there. Okay, get the formula. And then we want to fill n for negative 380. So t sub n is negative 380, 52, and then negative 8n. And then subtract that. And so we get negative 432 divided by negative 8, which is 54.